channel Ignited Medicos. I am Nayana, today dealing with metabolism of phospholipids. The phospholipids are present in membrane structures, and the functions of phospholipids are blood clotting and supply of the arachidonic acid for the synthesis of prostaglandins. Arachidonic acid is the essential phospholipid. Now, the synthesis of phospholipid takes place in endoplasmic reticulum. If we see the process, the glycerol 3-phosphate is converting into phosphatidic acid. This is the step that takes place in the synthesis of triacyl glycerols. From the synthesis of triacyl glycerols, the phosphatidic acid is produced. The phosphatidic acid is produced. Now this phosphatidic acid will convert into 1,2-diacylglycerol and CDP-diacylglycerol, which are the important compounds that further steps takes place in the production of some other important phospholipids. Now, the phosphatidic acid, when the phosphatidate phosphohydrolase acts on this and makes into 1,2-diacylglycerol, and then here we can see that phosphate group is now released, and by the attachment of OH it is replaced. Now the phosphatidic acid will get converted into CDP-diacylglycerol by the enzyme CTP phosphatidate cytidyle transferase. Here also we can see that there is a attachment of other P bond and the cytidine to this P phosphate group of phosphatidic acid. We can easily remember this like P gives rise to 1,2D plus CDPD, where D refers to diacylglycerol in the both cases. P is phosphatidic acid. Phosphatidic acid will give rise to 1,2-diacylglycerol plus CDP diacylglycerol by the enzymes. We can easily remember this enzyme also. Here see, phosphatidate phosphohydrolase. Phosphatidic acid is also known as phosphatidate. Now hydrogen hydrolase and phospholase will take place. So phosphohydrolase, like this, phosphatidate phosphohydrolase. Here also CTP phosphatidate cytidyle transferase. Here cytidine group is transferred from here to this phosphate group of phosphatidic acid. So CTP phosphatidate cytidyle transferase. Now I said that 1,2-diacylglycerol and CDP diacylglycerol will give to the important compounds. Let us see that what are those important compounds and how it forms. First thing, the formation of lecithin and cephalin. The other name of lecithin is phosphatidyl choline. The other name of cephalin is phosphatidyl ethanolamine. Now, the choline will undergoes phosphorylation by the conversion of ATP to ADP and becomes phosphocholine. And then this phosphocholine will convert into CDP choline by the conversion of CTP to PPI, that is inorganic phosphate. Now this CDP choline, when combines with 1,2-diacylglycerol that formed in the previous steps, will give rise to phosphatidyl choline, which is also known as lecithin. See, first choline, next phosphocholine, next CDP choline, and then it combines with 1,2-diacylglycerol to produce the lecithin, which is also known as phosphatidyl choline. Like this only, ethanolamine will get converts into phosphoethanolamine by the conversion of ATP to ADP. First phosphorylase, addition of phosphate to the compounds ethanolamine. Next CTP to PPI, that is by the conversion of CTP to PPI it produces CDP. Then this is known as CDP ethanol amine. Then this compound, if it combines with 1,2 diacylglycerol, it gives ethanol amine, that is phosphatidyl ethanol amine. This is also known as cephalin. You have to remember the only steps as first phosphorylation, the next CTP converts to PPI, so it gets converted into CDP. Next, this combines with 1,2 diacylglycerol, and where CDP converts to CMP, and choline will occupies a position around the phosphate of this compound, that is diacylglycerol, where see here OH is here. This OH is occupied by the P and choline, phosphate group and choline. I have to remember only this thing. OH is replaced by phosphate and choline. Here also first phosphorylase, so the ATP is converted into ADP. Next step is CTP is converted into PPI, that is inorganic phosphate, where this gives CDP ethanol amine. Then it combines with 1,2 diacylglycerol to give phosphatidyl ethanol amine, that is cephalin. You remember this, OH is here and this is replaced by O phosphate group and ethanol amine. The next formation is phosphatidyl inositol and phosphatidyl glycerol. This is formed from CDP diacylglycerol, which is formed from phosphatidic acid. Now, the phosphatidic acid will give rise to CDP diacylglycerol. Then this CDP diacylglycerol will give phosphatidyl inositol and phosphatidyl glycerol. Let's see how this happens. Now, the CDP diacylglycerol will give rise to phosphatidyl inositol by the enzyme CDP diacylglycerol inositol transferase. When this transferase will come, you have to remember that something is transferring to another thing. Here, see is the cytidine is replaced by inositol molecule to get phosphatidyl inositol. This is the simplest thing. Conversion of CDP diacylglycerol to phosphatidyl inositol takes place by the enzyme. Enzyme is also easy for the remembrance because there is a transfer of cytidine by inositol. So transferase is the enzyme. Now what is the main enzyme? CDP diacylglycerol inositol. For this compound, the cytidine is transferred into inositol. So the enzyme is CDP diacylglycerol inositol transferase. Now, how this happened? The CDP diacylglycerol is converted to phosphatidyl inositol by the enzyme CDP diacylglycerol inositol transferase. Now we can see CDP diacylglycerol is then converting into phosphatidyl glycerol. How this happens? The cytidine group is replaced by glycerol 3-phosphate. So it becomes phosphatidyl glycerol 3-phosphate. By the enzyme, for this inositol, add glycerol 3-phosphate. It becomes CDP diacyl glycerol 3-phosphate transferase. This enzyme converts CDP diacylglycerol to phosphatidyl glycerol 3-phosphate. Now, this phosphatidyl glycerol 3-phosphate is then converting into phosphatidyl glycerol by conversion of H2O2PI, that is inorganic phosphate is released and water is added, so it forms glycerol again. So this becomes phosphatidyl glycerol. Now the CDP diacylglycerol is formed to phosphatidyl glycerol. then this phosphatidylglycerol will become cardiolipin. This is also known as diphosphatidylglycerol. Here the diphosphatidylglycerol, another molecule of diphosphatidylglycerol will add, and the removal of one glycerol will give diphosphatidylglycerol. This is the only phospholipid that is antigenic in property. Now the next compound is phosphatidylserine. How this happens? It is a cyclic process and a short process where the phosphatidylethanolamine is converting to the phosphatidylserine. How this happens? The ethanolamine place is replaced by serine compound, so it becomes the phosphatidylserine. The ethanolamine is replaced by serine. In the place of ethanolamine, serine will occupy and the ethanolamine will remove from this compound. So it becomes phosphatidylserine. Now how this phosphatidylserine gets converted into phosphatidylethanolamine. This phosphatidylserine by the decarboxylation process, this gets converted into phosphatidylethanolamine. It's a very easy thing and so simple and circular. First step is serine is occupying the ethanolamine place, so it becomes phosphatidylserine. Now from this compound decarboxylation takes place to form phosphatidylethanolamine. It's so simple. Now the formation of sphingomyelins takes place, and we can see how this happens. The sphingomyelins are the phospholipids containing a complex amino acids and sphingosins instead of glycerol. Now we can see how the sphingomyelins formation takes place. Palmitoyl-CoA and serine combines to form sphingosin. This is the main intermediate for the formation of sphingomyelins. How? The palmitoyl-CoA plus serine will give sphingosin. Now the sphingosin is converted into ceramide by the acyl-CoA transferase. Like for the sphingosin, the acyl group will add and becomes ceramide. Now this ceramide will become sphingomyelin by the conversion of CDP choline to CMP. Now the process like palmitoyl-CoA plus serine will give sphingosin. This sphingosin by the addition of acyl group will become ceramide, and the ceramide becomes sphingomyelin by the conversion of CDP choline to CMP.